Okay, so let's look at some examples of how you can balance chemical equations. Let's start with a pretty simple example. Here we're going to look at zinc, which is a metal, react it with an acid, hydrochloric acid, HCl is the symbol for that, hydrogen and chlorine, and that gives zinc chloride and it gives off a gas, hydrogen gas, H2. Now the thing about this equation is that it's not balanced. Just to check that, let's just do a tally of all the elements on each side. So let's look at zinc, hydrogen and chlorine, and let's look at what is on the reactant side and on the product side. So this little table here is for helping me work out how to balance this equation. So the number of zincs on the reactant side, well, there's one on the product side. The number of hydrogens, there's one on the reactant side, and there are two on the product side. So already I can see it's not balanced. Let's look at chlorine. Chlorine has one on the reactant side. On the product side there are two there. So there's two chlorines. Now, it's not balanced. When we are balancing equations, it's really important that we don't go through and say, oh well, listen, I'll balance this, I'm just going to chuck a 2 there and a 2 there and it's all sweet, hey. No, can't do that. The main reason is that creates a different molecule, alright? So H2Cl2 would be some crazy molecule with 2 hydrogens and 2 chlorines, okay, all bonded together somehow, okay? I'm not even sure if that exists. Maybe it is, but even if it does exist, right, it's different to this one. That's hydrogen chloride, as it were, which is hydrochloric acid, okay? It's not the same as this H2Cl2 business. So we can't go doing that, so I'm going to rub that out. Alright, and I'm going to get rid of these little bits of graffiti here. Now, the only way I can change things here is by changing the numbers of these hydrochloric acids, okay? So if I look at this, I want 2 hydrogens and 2 chlorines on the reactant side, and I could do that if I put a 2 out the front, because if I say 2HCl, what 2HCl means is 2 of these little guys separate, so 2 actual molecules, so that's a hydrogen and a chlorine there. So 2HCl is quite different to H2Cl2, alright? That's another molecule which doesn't even exist in this equation, okay? So that's all I'm saying when I say 2HCl, and if I do that, that becomes 2 and that becomes 2 and the equation is balanced. Oh, big red tick. There we go. Pretty easy for that one. Let's do a harder example. So let's look at pentane, hydrocarbon. Okay, so C5 H12. You can already tell this is going to be hard, isn't it? Look how many hydrogens are there. Plus oxygen. Okay, what I'm doing here is I'm burning some pentane. Alright, so think of petrol, or no, it's actually a bit too light to be petrol, like aircraft fuel or something like that. And then I put a match to it and get it reacting with oxygen. It's going to release a lot of energy, and one of the things that these hydrocarbons release is carbon dioxide, nice greenhouse gas for you, and water, pretty harmless. Okay, how do we balance this? Well, listen, we just follow the same method that we've been following. So we do a tally of the different elements, so carbon, hydrogen and oxygen. Let's look at the reactants. That's a funny oxygen, isn't it? Look, I'm just got to fix that, don't I? Okay, oxygen, yeah. Okay, reactants and products. Carbon, 5 on the reactant side. Oh, only 1 on the product side, so that's a problem. 12 on the reactant side for hydrogen. 2 on the product side. 2 oxygens are on the reactant side. See, so 2, and on the product side we've got CO2. So, oh, and we've got this other oxygen here, so don't forget that one. So that means we've got 2 oxygens. We've got 3 oxygens on this side. So let's try to balance. Listen, the way we've got a lot of balancing to do in this formula, this chemical equation. So what I recommend doing is just starting with one thing that you see in one molecule here and one molecule on the reactant side, and balancing one element. So let's balance carbon. We got 5 carbons there. We got 1 here. So I can balance the carbon there. Let me change colors here. I can balance this by having 5 CO2. Okay, so C5H12 plus that gives 5 CO2. So if I do that, then I'm going to have 5 carbons on the product side. So good, sorted there. But I'm going to have a lot more oxygens, aren't I? So I'm going to have another, I'm going to have 10, I'm going to have 11 oxygens now. Alright, so the carbon's looking good, but diabolical for hydrogen and oxygen. So let's balance the hydrogen next. Okay, so we've got hydrogen there, that's only in 1 molecule there and 1 molecule here. I think the oxygens are going to be the hardest one since it occurs in the most molecules here. So let's leave oxygen till the end, okay? Hydrogen, I've got 12 here, I've got 2 here, so I guess what I need to do is I need 6 H2O here. So that would mean I'm going to be balanced out in my hydrogens now, so that's going to be 12 on the reactant side, so 6 H2, so that means 12 of those, all sweet. Now where am I with the oxygen? Still 2 on that side, and then on this side, on the product side, I've got 10 there and I've got 6 there, so this has gone all the way up to 16. Okay, but it's the only thing I've got to fix up now, oxygen. So 16 oxygens in the product. That means on the reactant side I must have 16, so I've just got O2 there, so to make O2 16 oxygens, so I guess there must be 8. That means there'll be 16 on this side, and we've balanced that equation. C5H12 plus 8 O2 gives 5 CO2 plus 6 H2O. Now that was a little bit daunting, but you can see we just broke it down into steps. We started with balancing the elements which only appeared in one place on each side. So carbon is only in one place, that's here, and it's only here. So I balanced the carbons first. Then I did the hydrogens because the hydrogens are only here and here. Once I got those two balanced, then it was a bit kinder to me, and it was sort of obvious that it was 8 oxygens there. Alright, I hope that helps. That's all for now. Bye.